In this video, we're going to look at some more work with improper integrals. So we're finding the area from 2 to 5 of 1 over the square root of x minus 2. So I've included a graph here so you can see why it's improper. It's because we have an asymptote, a vertical asymptote, at an endpoint. So that's what makes it improper. Now, if you remember from before, we start with a rewrite of this. We rewrite limit as b approaches infinity. Oh, excuse me. As b approaches 2, because that is the problem, 2. We go from b to 5. And I'm going to write this as x minus 2 to the negative 1/2. Okay. So the antiderivative would raise the power. So it would be the positive 1/2 divided by the power, so 2. And we're going to evaluate this at 5 and b. And we're taking the limit as b approaches 2. So I plug in 5, and I get 2 times the square root of 3 minus 2 times the square root of b minus 2. And I take the limit as b approaches 2. Well, the first thing you always try with the limit is to plug it in, and if I do that, I get the square root of 0, which is 0. So this is just 2 square roots of 3. So it actually worked out. Even though there is an asymptote, a vertical asymptote at an endpoint, we actually were able to find the limit of the area. We're saying that as you get closer and closer to 2, the area will get closer and closer to 2 square roots of 3. Okay, let's do another one. This one is a little bit different. We're finding the area from 0 to 3. Okay, so from 0 to 3. But the problem is a vertical asymptote at 1. So we actually here would need to split this into 2 integrals. We'd need to go from 0 to 1. And we need to go from 1 to 3. And we, of course, would add those two together. Okay. Now, we should rewrite this. Of course, 1 is the problem. And really, you could even make the case like 1 from the negative side is the way you'd write this, because, of course, from 0 to 1, we'd be approaching 1 from the negative side of this. This one would be positive side. We go from b to 3. So the antiderivative would be the natural log of x minus 1. Evaluate at b and 0. Of course, this would be the same thing. It's the nice thing about it is they are the same antiderivatives. And we take the limit. Like that. Well, here if I plug in 1, I get the b, I get the natural log of b minus 1. Minus the natural log of, well, it's the absolute value of negative 1, so it's like that. Now I plug in 1 for b, and I get the natural log of 0, which is undefined. Well, that kind of derails this entire thing. The fact that I get an undefined answer there, it really is not going to matter what happens on the other side. Now I could do it. I could have the natural log of 3 minus 2, natural log of b minus 1. I'm going to run into the same exact problem right here once I take the limit. But it really wouldn't matter. As soon as one part of it is undefined or that limit doesn't exist, we say that the entire integral diverges. So we can't get an answer. There's not a limit that this area is approaching. So yesterday we looked at some examples where you were going to infinity and something like this, where it would go from 1 to infinity. But today we're looking more at a vertical asymptote. So if I look at this vertical asymptote at 0, so we're going to need to split this from negative 2 to 0. and from 0 to 3. So I'm going to rewrite this with a limit statement. So finding the antiderivative, we raise the power, divide. Okay. A lot of times it is nice to rewrite these with a positive exponent. So this would be negative 1 over 3x cubed. Evaluate at b in negative 2. And what you're going to find here is when you plug in 0, or you plug in b, I guess, you're going to get something that's undefined again. So just think about this. Once you plug this in, you have 3b cubed, but b, we're plugging in 0. That's undefined. So once again, it diverges. So the thing about improper integrals, you need to know why it's improper. You know, is it an asymptote? Is it going to infinity? Of course, going to infinity, those are easy to spot. But then you'll look for an asymptote. If the asymptote is at an endpoint, like our first example, then you just do one integral. But if the asymptote is in the middle, you have to split it in two and evaluate it, just like you always would have. Find the antiderivative, plug in the endpoints, and see what that limit is. And if any part of it comes out undefined or non-existent, we say that it diverges and we can't actually get an answer.